Hello, this is Jeff Rao from G4 Geomatic Resources in Houston, and today we're going to do the second video on the one-step field transformation. In this case, we can do a one-point localization using the CS20 and GS18. So the advantage of the one-step is we can shift into one local point. In this scenario, we want to rotate into a direction, and it might be we don't want to hold that second point. Maybe the second point, like on a boundary, that was disturbed, and we shot it in the inverse, the distance didn't quite check out, so you don't want to warp into that, but just hold that direction to find these other points. So once again, we can shift and transform into a ground system and use this to locate the other points to update. Okay. Here's a schematic of a boundary survey just to try to illustrate. So let's imagine we found this point in good shape. We found the second boundary point over here. It looked kind of disturbed, but we want to hold this line here. It's not the best geometry, but we just want to use this to get on that local system. These other points, all these boundary points have been calculated by the office. They're uploaded. So we can use this to stake out, find these points. We probably find them within a few tenths accuracy or 3 to 5 centimeters. And the goal is these green location at this point was disturbed. We will tie this point down, this point, and this point, and use these 4 points in a one step. But as we're walking on this large tract of land in heavy brush, we can use the GPS to try to find these boundary corners and locate them in real time. Okay. All right. So once again, we've got 2 points we're going to rotate into from true north. We'll rotate into that local coordinate system, however it's defined in that bearing. And then in our case here at the office, we'd hit the first point. Let's say the second point, number 4. So we're going to hit number 3, the second point, and pin it down to point number 3. Then the second point, number 4. We feel that it was disturbed, but we still want to hold that line and use this to localize, get on that local coordinate system and find these other boundary corners that might not be in an easy spot to locate. Okay, let me just fire up the video here. So once again, here's a CS20. We have a job set up here called Cravens Field. Once again, we're dialed into the network. We have a fix. And what we're going to do is come back in and utilize the create coordinate system. We also have our control job here where we updated and uploaded the coordinates that were supplied like in the previous video. Okay, so we'll hit the application called create coordinate system, and in this case we want to do the one step. Okay. So we'll click on the application and there it goes into the one step. All right, so hit OK. It says, what do you want to call the name of this transformation? We'll call it Cravens -1 step or 1.1 step. Okay. And once again, this is where we define our WGS84 points. We have the field job and the local points are under control. That's where we updated. And then we check this box here for the 1-point localization method. It's really important. Okay. So once that's all set up, just like in the previous one, it confirms the name. We'll change the height mode to orthometric. We'll hit OK. And we don't use a geodo model. And here, what we want to do is it says choose the first point position height that you want to match up. Now I want to update this to point number 3. Point number 3 is solid and it defaults. So once again, this will pull it from that job, our field job, and the local point will be pulled from the control job. Okay. So what we want to do is we want to update that and change that to point number 3. That's the point that we shot in multiple times in the field. And then it says what point will scroll down the control job is CP3. We'll hit OK and I'll pin that 84 point with that local point to get us on the local system. And the next screen will define how we do our direction. Okay. So since you want to use WGS84 North, we'll click on that arrow to scroll down and open up different options. And we want to scroll down to 2 WGS84 points. Okay. And in here, what we want to do is it says point 1 and point 2. These are the points that we shot in with WGS84. So we'll pick 3 and 4. And this is the true azimuth, WGS84 azimuth. Okay. And what we'll do now is it'll come down, says required azimuth. We'll highlight that field, and then we'll hit the F2 inverse button. And what this will do is it'll go pull our points points from our control job. Okay, it says, right, what's the required local azimuth? We'll pick CP3 and CP4. These were the points that were calculated. That was the actual azimuth on that local deed for 1952, and that shows a rotation. So it'll hold on point number 3, it'll rotate that into that local system and it'll confirm that information. Then we'll just hit OK. And that's as simple as it is. It shows the results here. Then we'll hit F1 store. And now that coordinate system's updated. So we go back to our job, go to properties. There's our local coordinate system. And if we click on our star current position, we're now in that local, see our northern eastern's in the local coordinate system. That's great. Let's go hit a check shot. Hit stake points. We'll hit the control job and we're now on CP7. And now you can see we're within a few hundreds horizontal, 900s vertical. So that's probably within 2-3 centimeters horizontal, 3-4 centimeters vertical. So everything's looking good. And now we're in that local system. We can now start staking those other boundary points that are uploaded. And if we wanted to, we could update that one step and modify to add points if they tie in and to update our transformation. But this is just a quick way that we can rotate into a local boundary and find these other points that could be hard to find. Okay, so let's take a quick look back. Once again, we rotated in. Now we can navigate to these points, locate them, flag them up. And what I'll do real fast, just want to go into infinity real fast. So once again, right now I've got this in state plane, and this shows the orientation of the points we shot in state plane. The local coordinate system had a different orientation. We sort of rotate around 227 degrees. So I'm changing the coordinate system to the local one step. It's kind of hard to see. And now see it shifted because we had north up on this fence line here. So once again, we have now point number 3, point number 4. If we came in here and took a look at our, once again, our local coordinates. And once again, here's our, it's hard to see the point ID, but these are local coordinates, elevations, and now we're in that local system. So once again, it's just a quick way to rotate, another handy tool to have at our disposal. Okay, and once again, this is the picture of the G14. So if you need any help, just feel free to reach out to myself. John handles HES scanning, survey support, and sales. Ronald's in service. Stacy handles supplies and service. And Logan and Ray are in the icon construction. And once again, here's our contact information. So if you're ever in the Houston area, please stop by our office. We'd love to chat. And if you have any needs or any questions, please feel reach out. Here's our emails and phone numbers if you need any assistance. So I hope you found this beneficial. Until next time, have a great day and take care.